Thousands of years before electricity or machines, people across the world built monuments that still defy explanation. They carved mountains into temples, moved stones heavier than trains, and aligned their cities with the movement of the stars. Somehow, without iron tools or engines, they reached a level of precision that still amazes modern engineers. In Egypt, the base of the Great Pyramid points almost perfectly to true north, with an error smaller than a single degree. In southern Turkey, ancient pillars at a site called Gobekli Tepe rise in perfect circles, carved more than 11,000 years ago, long before written history began. In South America, the walls of Sacsayhuaman fit together so tightly that a piece of paper cannot pass between them. These places are separated by oceans and by time, yet they share something mysterious. Impossible skill at impossible times. Archaeologists have studied these sites for generations. They have found evidence of tools, ramps, and years of human labor. But even with those explanations, one question remains. How did the people of the ancient world know so much? How did they measure with such accuracy? How did they understand the movement of the stars, the weight of stone, and the strength of the earth beneath them? The mystery deepens when we notice the same patterns appearing everywhere. Civilizations that never met followed the same rules. They built with symmetry, with balance, and with alignment to the heavens. The pyramids of Egypt, the ziggurats of Mesopotamia, and the temples of the Americas all seem to follow one principle. That harmony with the universe could be written in stone. To the ancients, knowledge was sacred. Science and faith were not separate. They believed the world worked according to laws both physical and divine, and their temples, observatories, and monuments were built in harmony with those laws. Their technology was not only about tools, but about understanding. They studied the sky, the seasons, and the cycles of time itself. Some discoveries reveal how advanced that understanding truly was. A clay tablet from Babylon shows complex trigonometry more than 1,000 years before Pythagoras. The Antikythera mechanism from Greece, found in a shipwreck, worked like a mechanical computer to predict eclipses. Ancient engineers in China built instruments that detected earthquakes long before modern seismographs. These were not isolated achievements. They were signs of a shared curiosity, a search for order in the universe. Perhaps what we call technology today once had a different meaning. Maybe it was not about power, but about balance. The people of the ancient world built in harmony with nature, not in defiance of it. Their inventions were made to connect, not to control, and in that connection, they found a form of wisdom that we may have forgotten. As we walk among their ruins now, we are not just seeing the past. We are standing inside questions that still have no answer. Were these civilizations truly primitive, or were they carrying knowledge that has been lost to time? Tonight, we will explore those mysteries. From forgotten temples carved in stone to cities aligned with the stars, we will follow the traces of a lost science. A science that reminds us that progress does not always move forward. Sometimes, it begins in the past. If you enjoy stories about ancient history and lost civilizations, do not forget to like this video, subscribe for more, and share your thoughts in the comments. What do you think? Did the ancients know more than we believe? We have already made detailed videos about Gobekli Tepe and Giza, so in this episode we will only touch on the key facts. You can find both on our channel after watching this one. In the hills of southeastern Turkey, where the dry wind carries the scent of dust and stone, lies a place that changed how we see the beginning of civilization. Its name is Gobekli Tepe. In 1994, a German archaeologist named Klaus Schmidt from the German Archaeological Institute began digging into a hill that locals had long ignored. What he found buried beneath the earth was not the remains of a simple camp or village. It was a monument built by hands that should not have known how to build. Beneath the soil were massive T-shaped pillars carved from solid limestone. Each stood 5 to 7 meters high and weighed as much as 20 tons. Their surfaces were covered with intricate reliefs of foxes, snakes, lions, vultures, and abstract symbols. These carvings were not random decoration. Many appeared carefully placed, perhaps representing constellations or celestial alignments. Some researchers noticed that the central pillars of one enclosure point toward the star Sirius, the brightest star in the night sky. Radiocarbon dating showed that these structures were built around 9,600 years before the Common Era, a time when humans were thought to be only hunter-gatherers. Gobekli Tepe was older than agriculture, older than pottery, and older than any city known to history. It forced scientists to rethink the order of human progress. Before this discovery, archaeologists believed that organized religion and monumental architecture appeared only after farming began. The logic seemed simple. People settled, grew crops, formed villages, and eventually built temples. Gobekli Tepe reversed that timeline. It showed that people could come together to build something sacred long before they learned to plant fields. In doing so, they developed planning, coordination, and social organization, the very foundations of civilization. This temple may have come before the city, not after. The site itself consists of a series of circular stone enclosures, each centered around two towering pillars facing one another. Around them, smaller pillars form a ring, as if encircling the heart of a ritual space. These enclosures were not built all at once. Ground-penetrating radar studies in 2021 revealed multiple layers beneath the visible site, suggesting that new structures were built on top of older ones, layer by layer, across centuries. Whoever built Gobekli Tepe had a long-term plan. They understood how to move massive stones, how to balance weight and geometry, and how to organize hundreds of workers. What is perhaps most remarkable is what they chose to do after centuries of use. The builders deliberately buried the entire complex under tons of earth and debris. They covered their own creation as if preserving it for another age. No one knows why. Some believe it was a ritual act, a symbolic closing of an era. Others think it was meant to protect something sacred. Whatever their reason, that decision allowed the site to survive almost perfectly until its rediscovery. The more we learn about Gobekli Tepe, the clearer it becomes that human understanding of engineering and design began far earlier than we once believed. Thousands of years later, along the banks of the Nile, another civilization rose and carried that same spirit of design to a new level of perfection. The ancient Egyptians turned stone into science. At Giza, they created monuments so precise that they still surpass many modern structures. The Great Pyramid, built for Pharaoh Khufu around 2,500 years before the Common Era, stands as one of the greatest engineering achievements in human history. Each of its sides measures more than 230 meters, and the base aligns almost perfectly to true north, off by less than a fraction of a degree. The largest stones, weighing up to 80 tons, are fitted together so tightly that not even a human hair could slip between them. For centuries, the question of how it was built remained unsolved. Myths spoke of divine help or lost technology. But in 2013, a discovery brought the mystery closer to reality. Near the Red Sea, archaeologists uncovered a set of papyrus documents now known as the Papyrus Mera. These were the records of an overseer named Mera, who described his daily work transporting massive limestone blocks along a network of canals to Giza. His writings revealed a complex logistical system that used water channels and wooden boats to move stone from quarries to the construction site. Once at Giza, the blocks were lifted into place using ramps and levers, a combination of human coordination and mechanical understanding. Still, even this explanation leaves room for wonder. In 2005, French architect Jean-Pierre Houdin proposed that an internal spiral ramp might run within the pyramid itself, allowing workers to raise blocks without the need for an enormous external structure. His model, based on computer simulations, fit the dimensions and physics of the pyramid almost perfectly. Whether or not this theory proves correct, it shows that the builders of Giza were not improvising. They were thinking, calculating, and designing on a scale rarely matched since. Yet even Egypt's grandeur holds mysteries that go beyond engineering. Near the pyramid stands the Great Sphinx, a monument whose age remains disputed. In 1992, geologist Robert Schoch from Boston University studied the erosion patterns on its body. He found deep weathering caused by rainfall, not desert wind. The last time heavy rains fell in that region was around 12,500 years ago, long before the accepted age of the Sphinx. If his findings are correct, the statue could belong to a much older epoch, perhaps one that predates known Egyptian civilization. 2 years later, researcher Robert Bauval proposed another idea. He observed that the three pyramids of Giza align with the three stars of Orion's belt. Using astronomical data, he showed that this alignment fits the sky as it appeared around 10,500 years before the Common Era. To him, the pyramids were not random monuments, but part of a design meant to mirror the heavens, a message written in stone across time. Many Egyptologists disagree, yet even the skeptics admit that ancient builders possessed an advanced grasp of astronomy. Every corner, every passage, every chamber of the pyramid corresponds to celestial geometry. The structure was not only a tomb, it was a map of the cosmos. From Gobekli Tepe to Giza, the thread of human ingenuity stretches across thousands of years. Both sites show that early civilizations saw the world as a system of patterns and forces that could be understood and shaped. They were engineers not because they had machines, but because they had vision. They built to last, to align with the stars, and to leave behind proof that they once understood something fundamental about the universe. In the mountains of Lebanon lies one of the most puzzling engineering sites of the ancient world, Baalbek. Known to the Romans as Heliopolis, the city of the sun, it stands on layers of stone so massive that no modern crane could lift them. Even today, the site defies explanation. At the base of the Temple of Jupiter are three enormous limestone blocks, each over 20 meters long and weighing around 800 tons. They form what is called the trilithon, a foundation so precisely leveled that the difference in height between the stones is less than a few millimeters. But that is not the most astonishing part. Just a short distance away, half buried in the ground, lies the stone of the pregnant woman, a single monolith estimated at around 1,000 tons. For centuries, it was believed to be the largest stone ever quarried by human hands. Then, in 2014, archaeologists from the German Archaeological Institute made a new discovery. Beneath that massive block, they found an even larger one, the so-called Forgotten Stone. It measured nearly 20 meters in length and weighed an estimated 1,650 tons. The precision of its surfaces suggested that it had been fully shaped, waiting to be moved, yet somehow it was left behind. It remains the largest known building stone ever carved in human history. What makes Baalbek extraordinary is not only the size of these stones, but the accuracy with which they were cut and positioned. The surfaces are so flat that they deviate by only a few millimeters. The joints fit together with an almost mechanical precision. No mortar was used. Each block was placed perfectly in line with the others, forming a foundation that has endured for thousands of years without shifting. How were they moved? The quarries lie more than a kilometer away, and the terrain rises steeply toward the temple platform. The stones were not rolled, as their size would have crushed any wooden roller. Some theories suggest they were dragged along ramps with wet clay or oil to reduce friction, requiring tens of thousands of workers. But no records describe such a feat. Others propose that the builders understood principles of leverage, counterweight, and vibration that we have forgotten. Modern engineers who studied Baalbek note that even with today's heavy equipment, lifting and aligning stones of that size would require custom-built cranes and modular transporters. Yet these stones were shaped and placed nearly 2,000 years ago, or possibly earlier depending on which layer of the site one studies. The precision, the stability, and the sheer audacity of Baalbek show that the ancients possessed a practical understanding of gravity, material density, and mechanical advantage far beyond what is usually credited to them. In western India, near the town of Ellora, stands the Kailasa temple, a monument that challenges imagination. Unlike other temples built block by block, Kailasa was carved from the top of a mountain downward, sculpted from a single mass of volcanic basalt. It is the largest monolithic structure ever created by human hands. Built in the 8th century during the reign of the Rashtrakuta dynasty, the temple was not assembled, it was excavated. Ancient builders removed an estimated 200,000 tons of rock, cutting down through the mountain to reveal columns, stairways, and courtyards all carved from the same stone. Every wall, every sculpture, and every passage was planned in advance. There was no margin for error. A single mistake could not be corrected without destroying the symmetry of the entire structure. The temple measures more than 30 meters in height and nearly double that in length. 2 life-sized elephants, also carved from the bedrock, stand as guardians at its base. The pillars and ceilings show intricate patterns that mirror precise geometric ratios. Archaeologists and engineers who examined the site agree that the builders must have followed a complete three-dimensional blueprint before the first strike of the chisel. What makes Kailasa even more mysterious is its perfection. There are no visible signs of correction or rework, no layers or seams where separate phases of construction joined. The stone surface is uniformly smooth, suggesting not random carving but systematic planning. The alignment of columns and walls indicates a deep understanding of geometry and stress distribution. Modern imaging studies suggest that the temple's central axis aligns closely with solar patterns, hinting at both astronomical and architectural precision. To carve downward like this required not only extraordinary skill but coordination and logistics. Hundreds of workers would have needed to remove rock layer by layer, maintaining exact vertical and horizontal reference points over an area the size of a small cathedral. Every ton of stone had to be hauled away manually. Modern estimates suggest that even with advanced tools, such a task would take decades. Yet inscriptions show the Kailasa temple was likely completed in less than 20 years. Such speed and accuracy suggest the existence of techniques that went far beyond trial and error, a combination of mathematical planning, surveying instruments, and experience passed down through generations. Kailasa stands today not as a symbol of faith alone, but as a monument to the precision and coordination of ancient engineering. High on the Andean plateau of Bolivia, more than 3,800 meters above sea level, lie the ruins of Tiwanaku and nearby Pumapunku. Cold winds sweep across the empty plains, but the stones here speak of a vanished technology that seems impossible for its time. The blocks at Pumapunku are made of andesite and red sandstone, materials harder than granite. Some weigh over 100 tons, yet they are shaped with an accuracy that modern machinists find difficult to match. Many of the blocks are carved into interlocking H shapes, each fitting together like pieces of a mechanical puzzle. The edges are perfectly straight, the corners exact 90-degree angles, and the surfaces so smooth that they reflect light. When measured with modern instruments, the margin of error on some cuts is less than 1 millimeter. Drilling holes and recessed grooves line up with remarkable precision, as if the builders used templates or measurement tools calibrated to modern standards. However, no traces of iron or steel tools have been found. The Tiwanaku people are believed to have worked only with bronze, copper, and stone. Archaeologists studying the site have proposed several possibilities. Some suggest that the builders used abrasives like sand and quartz combined with water to grind the surfaces over long periods. Others point to the possibility of advanced understanding of resonance and vibration, the idea that sound or rhythmic motion could have been used to loosen or shape stone at a molecular level. Though speculative, this theory arises from the fact that many stones show no sign of chisel marks, as if they were cut with heat or vibration rather than impact. What is certain is the level of organization required. Each block had to be cut, transported, and fitted at an altitude where oxygen is thin and weather unpredictable. Without beasts of burden or the wheel, moving such stones would have required immense teamwork and technical control. The layout of Tiwanaku also shows astronomical planning. The Kailasa temple aligns with solstices, and the gateway of the sun depicts calendar cycles carved in relief. This combination of architecture and celestial mapping suggests that Tiwanaku was not merely a city, but a center of measurement, a place where science, religion, and engineering met. To stand before the stones of Pumapunku is to confront precision that feels out of time. Whether through lost techniques or extraordinary patience, the builders achieved a level of craftsmanship that rivals modern machinery. Their legacy reminds us that technology is not always a matter of tools, but of understanding, a knowledge of materials, angles, and forces that transcends the ages. On the plains of what is now Pakistan, archaeologists uncovered in 1922 two great cities, Harappa and Mohenjo-Daro. Both were more than 4,000 years old, yet showed urban planning equal to a modern grid. The streets ran north to south and east to west at perfect right angles. Every house was made of baked bricks of identical size, 28 by 14 by 7 centimeters, proving the use of standardized molds and a shared system of measurement. Each home contained a private bathing room connected to a covered drainage system beneath the streets. Terracotta pipes carried wastewater into main sewers lined with bricks and sealed with bitumen. Many of these drains had inspection holes and removable covers for cleaning. The city's Great Bath, a pool 12 meters long and lined with waterproof bitumen, shows an understanding of slope, pressure, and hydraulic control. Public wells were built with concentric brick rings that still draw water today. Granaries had raised platforms with ventilation ducts that kept grain dry. Archaeologists also found standardized stone weights, accurate to within a few thousandths of a gram, showing a precise decimal-based trade system. What they did not find was remarkable. No palaces, no fortresses, no weapons in quantity. The people of the Indus Valley lived in organized equality, their focus on infrastructure and hygiene rather than war. They mastered water management, city zoning, and civic engineering at a level the world would not see again for millennia. High in the Andes of Peru, the Inca built cities that could survive the shaking of the earth itself. At Sacsayhuaman near Cusco, huge polygonal blocks up to 120 tons fit so perfectly that even a razor blade cannot pass between them. Each stone is irregular in shape, yet all interlock in multiple directions. Modern laser measurements show that the joints tilt slightly inward. This design locks the stones together under compression and allows them to flex during earthquakes. The irregular edges scatter stress so cracks cannot travel in a straight line. The result is a structure that absorbs vibration rather than resists it. Centuries of earthquakes have damaged modern buildings nearby, but the Inca walls still stand. Their tools were simple hammerstones and bronze chisels, but their precision equals that of modern stone cutting. Experimental archaeology proves that shaping and fitting blocks with such accuracy demands constant measurement, patience, and an intuitive knowledge of rock behavior. The same intelligence shaped their road system, the Khapak Nyan. It stretched more than 30,000 kilometers across mountains, deserts, and jungles. The Incas built retaining walls, drainage channels, and suspension bridges woven from plant fibers. The Cuezhuachaca Bridge, still rebuilt every year by local communities, can hold several tons of weight. They achieved all this without wheels, without iron, and without written plans. Their engineering was based on observation, adaptation, and collective memory. Every structure worked with gravity, not against it. Deep in the Yucatan jungle, the Maya turned architecture into an exact science. The Pyramid of Kukulkan at Chichen Itza combines acoustics, astronomy, and mathematics in one design. When a person claps at the base of the staircase, the echo that returns sounds like the call of the Quetzal bird. In 2004, researchers from the National Autonomous University of Mexico confirmed through acoustic testing that the pyramid steps scatter sound waves at intervals matching the bird's frequency. This is deliberate, not accidental. The pyramid also functions as a calendar. It has 91 steps on each side plus the top platform, totaling 365, the number of days in a solar year. During the equinox, sunlight strikes the northwest corner, creating the shadow of a serpent moving down the staircase. The timing of this illusion matches the solar angle within minutes, proving the builders could calculate the sun's path to a fraction of a degree. Nearby stands the circular observatory known as El Caracol. Its narrow windows align with the rising and setting of the sun during solstices and with the cycle of Venus. These observations allowed the Maya to predict eclipses and seasonal changes with extreme accuracy. Their calendar year differed from the true solar year by only 0.002 days, far more precise than the Julian system of Rome. Recent LiDAR surveys reveal that entire Maya cities follow astronomical grids linking temples across kilometers of jungle. The builders planned alignments within half a degree of celestial targets. Inside the temples, the proportions of the rooms amplify sound at specific frequencies, so chants and drums resonate evenly throughout the space. The Maya used architecture as instrumentation. Each structure measured the heavens, the seasons, and the movement of sound. Their combination of geometry, vibration, and light shows a mastery of natural law equal to modern physics in concept, though expressed through stone. Long before Egypt raised its pyramids or the Indus people built their cities, a civilization emerged between two rivers, the Tigris and the Euphrates. It was called Sumer, the land between waters. Today it lies within modern Iraq. but 5,000 years ago it was the birthplace of almost everything we now call civilization. Here, in the cities of Ur, Uruk, and Eridu, humanity first began to write. Around 3,200 years before the Common Era, the Sumerians developed cuneiform, a script pressed into wet clay with a reed stylus. It began as a system for counting grain and trade, but soon grew into a tool for recording stories, laws, and the movements of the stars. In those wedge-shaped symbols lies the first record of knowledge itself, proof that humans had learned to store thought beyond memory. The Sumerians also measured the world in ways that still shape our lives. They created a mathematical system based on the number 60. 60 seconds make a minute, 60 minutes make an hour, and 360 degrees form a circle because of them. This sexagesimal system allowed easy division and became the foundation of both astronomy and geometry. They mapped the heavens, noting the paths of Jupiter and Venus, and used those cycles to track time and predict seasons. Their priests and scholars were not separate from their engineers. To them, mathematics was divine order made visible. By 2,100 years before the Common Era, Sumer had also given the world its first written laws. The Code of Ur-Nammu, carved into tablets long before Hammurabi, established standards of justice and punishment. It showed a society governed not only by kings and gods, but by rules that could be read and remembered. Law itself became a form of technology, a system for maintaining balance among people just as irrigation maintained balance in the fields. Their cities reflected that same balance. Ziggurats rose above the plains, massive stepped towers built from millions of mud bricks. These temples were more than monuments. They were engineered structures with drainage systems and inner chambers that regulated temperature and moisture. At their base ran networks of canals that carried water through the city, proof of careful planning and collective labor. Sumerian architects understood how to shape their environment to serve both faith and function. From writing to measurement, from law to architecture, Sumer set the blueprint for everything that followed. The knowledge born between those rivers flowed outward, carried by traders, scholars, and stories, shaping Babylon, Egypt, Greece, and beyond. When we read, when we measure time, when we build according to plan, we are still following the logic of Sumer. Their temples may be dust now, but their ideas endure. They remind us that the pursuit of understanding began not with machines, but with the human will to measure, to record, and to build a world that made sense. When historians speak of technological revolutions, they often think of modern times. But the foundations of nearly everything we use today were built thousands of years ago by 4 civilizations whose inventions still shape the world. The Romans were not the first to build cities, but they perfected the science of construction. Their greatest innovation was concrete. Roman concrete, known as pozzolana, was made by mixing volcanic ash with lime and seawater. The chemical reaction that followed produced crystals of aluminum turbomorite, a mineral that continues to grow stronger with time. Modern engineers have tested samples from ancient harbours such as Cosa and Pozzuoli, and found that Roman concrete actually becomes harder when exposed to seawater, a property modern concrete still struggles to replicate. Some Roman breakwaters have stood for more than 2,000 years despite constant waves and salt corrosion. This durability comes from a self-healing reaction. When cracks form, water seeps in and reacts with unhydrated lime, forming new binding crystals. In effect, Roman concrete repairs itself. Their understanding of hydraulics was equally advanced. The aqueducts that supplied water to Rome and its provinces followed a gradient of only 0.15%, meaning a drop of just 15 centimeters per 100 meters. This precision kept the flow constant across valleys and hills. The Aqua Marcia, one of the largest, stretched more than 90 kilometers and delivered hundreds of millions of liters of water per day to the city. The Romans also built the first global logistics network. Their roads covered more than 400,000 kilometers across Europe, Africa, and Asia. The phrase, "all roads lead to Rome," was not metaphorical. Each road was layered with stone, gravel, and lime mortar, crowned slightly in the center for drainage. The average deviation from level was less than 1 degree. Some of these roads, like the Via Appia, built in 312 years before the Common Era, are still used today. They also developed surveying tools such as the groma and the chorobates for leveling terrain, achieving millimeter precision without modern optics. Together, Roman concrete, water engineering, and road systems formed an infrastructure so advanced that it remained unmatched for more than a millennium. The Phoenicians were the chemists and navigators of the ancient world. Their cities along the Mediterranean, Tyre, Sidon, and Byblos, built their wealth through maritime trade, but their true legacy was chemical technology. They created Tyrian purple, the most valuable dye of antiquity. To make a single gram, they needed more than 10,000 murex sea snails. The process required crushing the shells, fermenting the glandular fluid, and heating it under controlled conditions to oxidize the pigment. The reaction produced a color-fast compound that grew brighter with sunlight. Modern chemists have identified this as dibromo-indigo, a molecule almost identical to synthetic indigo developed in the 19th century. The Phoenicians mastered this chemistry nearly 3,000 years earlier. They also invented the world's first phonetic alphabet around 1,050 years before the Common Era. Instead of hundreds of symbols like Egyptian hieroglyphs, their system used only 22 consonants representing sounds. This simplified writing and made literacy accessible to traders and sailors. The Phoenician script evolved into Greek, then Latin, and ultimately the alphabet we use today. In effect, their innovation turned language into technology. Phoenician shipbuilders also developed advanced hull designs using cedar wood reinforced with pegged joints. Their vessels were capable of long-distance voyages across the Mediterranean and possibly beyond the Strait of Gibraltar. Archaeological finds of shipwrecks show the use of waterproof resins similar to modern marine epoxy. When the Roman Empire transformed into Byzantium, its engineers preserved and refined the knowledge of the ancient world. One of their most mysterious inventions was Greek fire, a weapon that could burn even on water. It was projected from bronze tubes mounted on ships, creating streams of fire that clung to everything they touched. Historical records describe its use in naval battles during the 7th century, where it turned entire fleets into flames. The formula of Greek fire remains unknown, but chemical studies of residue suggest it may have contained petroleum, quicklime, and sulfur, possibly with ingredients that ignited upon contact with water. What made it unique was its pressurized delivery system. Byzantine ships used siphon pumps and pressure vessels to shoot the burning liquid in controlled bursts. This required knowledge of hydraulics, pressure, and combustion far ahead of medieval Europe. Their architectural mastery reached its peak in the Hagia Sophia of Constantinople, completed in 537 years of the Common Era. The dome, 31 meters across, appears to float above the central nave. Engineers achieved this illusion by using a ring of 40 windows at the base of the dome, allowing light to conceal its structural ribs. The pendentives that support it, curved triangular sections transferring weight to 4 piers, were a revolutionary concept in load distribution. Even with earthquakes and time, the dome still stands. Byzantine builders also used lightweight bricks and mortar infused with crushed ceramics, creating a flexible structure capable of absorbing tremors. Combined with precise geometry, this method allowed Hagia Sophia to survive for nearly 15 centuries without collapse. From Gobekli Tepe to Giza, from Sumer to the Maya, the people of the ancient world were never primitive. They understood the universe, the laws of matter, and the language of mathematics. These were the foundations of every science we now call modern. Across continents and millennia, their works share the same truth. They studied nature with patience. They used geometry, physics, and engineering to bring balance between earth and sky. Their hands shaped stone, but their minds shaped civilization. They measured time in stars, built cities aligned to the sun, and created machines that defied their age. Every monument, every line of writing, every fragment of metal proves that knowledge never stood still. It evolved, it adapted, and it endured. Ancient technology was never a mystery of superstition. It was the earliest expression of human intelligence, the proof that progress began long before us and will continue long after. If you enjoyed this journey through the brilliance of the ancient world, please like, subscribe, and share your thoughts below. Every story of the past reminds us what the human mind can achieve. Good night.